Today on Impossible Engineering, the biggest construction project in the history of New York City.
When you think about all the things that we had to do on this site to make it possible, I mean, the project is just astounding.
Over 16 million square feet of space, conjured out of thin air.
Every week we come up with challenges that I've never faced as an engineer.
And the pioneering historic innovations.
That flame gets pulled into the cylinder, causes an explosion, and that throws the piston up.
These boats are gigantic, and these are concrete boats. Can you believe that?
That made the impossible possible. Manhattan. 26 square miles of some of the most valuable land in the world. Demand for space is high, but surrounded by water, spreading out is not an option. The only way is up.
It's extremely difficult to get a large plot in Manhattan because everything's been spoken for over 100 years. So basically, when you do find a large plot, chances are it's because it's a railroad yard.
These vast expanses may be free of buildings, but they're strewn with tracks. Any construction seems impossible. But now on the west side of Manhattan, ambitious engineers are taking that challenge on. Hudson Yards, America's largest real estate development, is being built directly on top of a working rail yard.
The engineering on this site is incredible. But it's not one individual piece, right? There's a whole series of these things added together. I mean, not just you're designing a building, but then you're designing a complete specialty underlying structure to be able to support that. And unless you look out at the Western rail yards and see the trains there, you have no idea what's underneath us.
Changing the skyline is not just one new skyscraper, but 6, with more towers to come. Jeff Butler is the senior project manager on site.
Each of these buildings is an amazing building. We have over 1 million square feet of retail space. We have almost 5 million square feet of residential space, 10 million square feet of commercial space. It has no comparison in scale. There have been some great developments in New York, but I'm very excited that this is the biggest and best.
Built almost entirely over a giant base platform above a working rail yard, Hudson Yards covers a 28-acre site on the west side of Manhattan. Multiple megastructures are being constructed simultaneously, including the 3rd tallest tower in New York, an arts venue that can appear from nowhere, and a brand new park constructed from scratch.
When Hudson Yards is complete, we'll have 125,000 people here working, living, and playing every day. It's an entire city within a city.
But this ambitious $25 billion project poses immense engineering challenges. How do you build New York's highest external observation deck?
We're about 1,050 feet up. So the combination of engineering and understanding the construction sequence was really complicated.
In a city where blackouts can be catastrophic, how do engineers keep Hudson Yards running 24/7?
The firms at Hudson Yards absolutely cannot live with the threat of power outages.
But it's the specific site that poses the biggest problem of all. Jay Cross has masterminded the project from the start.
The actual plot of land is highly valuable because there's just only so much of it. There's rivers all around us. But the West Side Yards was always like the hole in the donut because it was all train tracks.
Spanning 7 city blocks, the West Side Yard was used solely as railway sidings for Penn Station. The audacious plan to construct on top of the tracks while the trains continue to run.
The engineering challenges were significant, not least of which we have to build over an operating rail yard. That logistically is a challenge unlike any other.
How is it possible to build directly over 30 active train tracks? Part of the answer is to be found 715 miles west of Manhattan. Architect Marty Sandberg is in Chicago, discovering how ambitious engineering helped a newspaper company overcome the confines of this crammed city.
In the 1920s, the Chicago Daily News was one of the best-selling papers in the city, and as a result, they had outgrown their current building and were on the search for a new home. Unfortunately, there was just simply no open land left at that time.
The problem was the same as that faced by the Hudson Yards team, the railways. At the beginning of the 20th century, Chicago was the busiest railroad hub in North America, with more lines radiating out than any other city.
The downside to being such a rail hub was, at the time, Chicago was literally choked off by rail yards on every side of the city.
But the Daily News decided to attempt an extraordinary engineering feat.
So this is the Daily News building. I'm a sucker for a gorgeous old limestone building, and this is a great example of it.
In a city hemmed in by train lines, how did they manage to find the space to build this? It was down to a new law known as air rights. The Daily News had bought from the rail company the right to build in the air above their tracks.
Essentially, the trains were only so high and they weren't really getting any higher, so they recognized that they were wasting a whole lot of space up above, and they saw this as a pile of money just waiting to be had.
Pouncing on this opportunity were architects John A. Holabird and John Wellborn Root Jr. Incredibly, they built the 26-story tower block directly on top of active tracks.
So when we look at the building now, you can't tell there's still a mess of train lines running back and forth underneath. Everyone coming in there day to day would never have any idea that they're still sitting over an active rail line.
This is what the engineers at Hudson Yards need to achieve. So how is it done here?
This is our sandbox of Chicago right here. All we need are areas where we can sink a couple of key foundations in between the trains. So we start by seeking out a couple of areas where we can sink these deep foundations down, trying to aim for the bedrock if possible. From there, we go ahead, drill our foundations down nice and steady, and all of a sudden ground level is no longer down here. We're up here 20 feet above.
The building could then be constructed on top of this platform, with the weight being supported directly by the pillars.
And we've just turned a train yard into some of the most valuable and useful land in Chicago. The city's happy, the railroad is happy, the person walking down the street is no longer standing next to a train. It really turned into a great solution for everybody.
Holabird and Root's incredible achievement led to an explosion in air rights. Railroad plots once shunned by developers were now worth millions. In New York City, the Hudson Yards development is thought to be the biggest air rights deal ever. $1 billion paid for fresh air above Manhattan's Western Rail Yard. Tracks covering 28 acres must somehow be straddled to build multiple skyscrapers, a supersized steel sculpture, an assortment of public buildings, and 14 acres of open space. And throughout construction, the trains below have to keep running.
We work basically at the mercy of rail traffic. So think of it as they own the basement and you own everything above the basement. And so of the 30 tracks, we were only allowed to close 4 tracks at a time for the purposes of construction. What we had to then do is weave all of the foundations for the buildings between the tracks to go down to rock.
The foundations for this massive 28-acre site draw on techniques used in Chicago over 90 years ago. The first step is to drill holes nearly 150 feet deep into the bedrock, which is 78 feet below the ground. Then, insert the supersized steel and concrete support columns known as caissons. 300 caissons support the entire development. Carefully located between train tracks, they take the weight of the steel frames for the tower blocks, as well as the giant 430,000 square foot base platform that surrounds the buildings. This concrete and steel platform creates a new ground level above the tracks.
The platform doesn't support anything except the open space where we're standing right now. So where the platform is underneath the buildings go right down between the tracks. They go all the way to rock. So the trick is in the foundations. That's where all the load transfer goes. The platform just fills in the space in between.
But while boxing in the active rail yard creates acres of new usable space, the incoming trains below are now confined underground, creating a fresh challenge.
When the trains come and bring commuters in, they drop them off in Penn Station and they park here for the day. We have engines running and just all the train activity is creating heat below us. It can get up to 150 degrees Fahrenheit, which is very hot.
The team had to find a way to keep the rail yards ventilated. To utilize the record airspace above, they will need a solution to keep the city's commuters cool. Building on top of a major transportation hub yields serious structural challenges, but it also presents the problem of temperature control. If the heavy train traffic were left unchecked, the temperature below the Hudson Yards project could reach up to 150 degrees.
Below you right now are about 5 jet engines. They're about 40 feet long, maybe 5 feet diameter. They're actually lined up right like this, and they exhaust through that shaft.
It's pretty exciting to be in here and to be able to see this. This is something that nobody ever gets to see and to experience when we go down here, right? To actually see down into here and be within the structure and to see the fan systems that are operating on either side.
Twin ventilation shafts at the plaza connect to 15 giant fans sandwiched within the tallest sections of the platform. Principal engineer Eli Gottlieb has special access to the restricted area inside the platform itself. The fans are installed at the plaza directly above the trains.
Well, welcome to the central fan plant underneath the yards. This is one of 3 fan plants that are actually down here. These fans are really part of the lungs of the facility that actually allow it to breathe. So these fans allow us to exhaust any of the heat generated by the trains out and pull in new, fresh, cooler air to maintain a tenable climate for everybody who's down there. These fans can fully exhaust the entire facility in 7 minutes of all the air that's here and completely replenish it.
But for Hudson Yards engineers, more impossible problems could jeopardize the project. Six skyscrapers will provide 18 million square feet of commercial and residential space, including a school, over 200-room hotel, and retractable arts center. All perched on 300 caissons squeezed between a network of train tracks. But in one critical section, this isn't possible, where the tracks converge in an area called the throat. Engineer Eli Gottlieb is one of the team charged with solving the problem.
From here, you can actually see that there's going through a lot of switching, and this switching allows them to fan out from the 4 tracks that they come in at to the 30 storage tracks. And you can imagine that if the tracks are spaced far apart, there's space in between them to be able to build a caisson and a column coming up. But as the tracks converge in together, you can just imagine that you're just running out of space in between the 2 of them to actually be able to install anything.
This area of the development is earmarked to have a tower block and a shopping mall built on top of it. If engineers can't span the 148-foot wide gap and support the buildings above, Hudson Yards will be left with a massive hole in its plans.
This is really a key problem on the site. All of that underneath us really narrows down the number of possibilities of what we can do to be able to support everything above.
Can a game-changing innovation from the British railway boom be the missing piece of the puzzle for the team at Hudson Yards?
Almost there now. Wow. And it's a long way down.
Physicist Dr. Andrew Steele is getting up close with the Worcester Railway Bridge in order to find out.
Wow. That's it? What a beautiful view. In the early 20th century, the UK railway system was undergoing a huge period of expansion. Not only were there more tracks, but there were also more trains, and these trains were much faster. And as they were getting faster, they were also getting heavier. And that meant that bridges on the railway network were being put under increasingly large strains.
Like the team in New York, engineers needed to find something strong and reliable to bridge the gap. James Warren was a merchant with no formal training in engineering. In 1848, he registered a patent that would revolutionize bridge design, the Warren Truss.
This is Warren's design. This repeating pattern entirely made of equilateral triangles, so triangles which are the same length along each side. Now, triangles like that have the advantage that they're incredibly strong. The railway track is above my head right now, and what that means is that as a train passes over the top of us, then its weight is distributed through all these different struts, and every single one of them can share that load. That means that all these individual beams are either in tension, so being pulled, or compression, so being squashed.
Previously, many bridge engineers had used vertical struts. So how much stronger was the triangle?
So they can both take one brick.
2 model bridges are being tested to the breaking point.
So in this simple design, all that load is mainly going through, well, honestly, just this vertical strut here. Whereas on the Warren Truss over here, all of that load with this triangular pattern of struts is being spread throughout the whole bridge. We're going to go for brick number 3. All right, brick number 4. Bit nervous about this one, to be honest. The question is, can it take a 5th? But a 6th, I think this is going to be it. Surely this time. Oh! Total structural failure there. You can see there's lollipop sticks everywhere. But the Warren Truss, it's still supporting that load pretty strongly because no individual lollipop stick is taking that much weight, and so, incredibly, it can hold all of that mass. The Warren Truss really was an incredible engineering innovation. And, of course, it's not just bridges. Wherever a weight needs to be borne and spread over a structure, you'll see these equilateral triangles holding them up. This incredibly time-tested design.
So how can engineers at Hudson Yards supersize this 170-year-old creation to support their mammoth project? Engineers at Hudson Yards are supersizing a 170-year-old creation to support part of their 7-story shopping mall and skyscraper. Where piled foundations are impossible, sandwiched between the retail space above and the converging rail tracks below, lie a series of 13-foot-high Warren trusses.
So we're inside the platform underneath retail, over all the switching of Long Island Railroad. We're standing basically within a bridge structure, right, where we're standing on the bottom of the bridge and there's the top of the bridge above us, and these Warren trusses are those main elements of the bridge that are spanning across.
In total, 14 giant trusses are used to span the crucial 148-foot gap.
By being able to use this truss structure and build a nice stiff bridge deck, that's actually really efficient for being able to support the buildings above.
The tower supported by the truss is not only the highest on the project, but, once it's complete, will be the 2nd tallest office building in New York. engineer Jay Cross has special access to its most incredible feature on the 100th floor, a 10-minute ride away in the temporary lift elevator.
The view changes so dramatically as you get higher and higher. It's amazing.
And it's the view from the top that inspired another phenomenal piece of engineering.
At first, we designed the building without an observation deck, and we realized how high we're going to be. So we challenged the architects to say, come up with the idea of an observation deck. We, of course, thought they were going to come up with something that was inside the tower. Instead, they came up with this protrusion, which was pretty darn dramatic.
This is the highest man-made outdoor observation area in the Western Hemisphere. Almost 1,100 feet up, it offers a brand new bird's eye view of the city below. But constructing a platform in the air calls for more impossible engineering.
At first, we weren't quite sure how to construct it. We thought maybe it would be like a bridge where you just kind of build piece and you inch your way out from the building. But the problem was we felt that we would have to have a lot of supporting scaffolding to do that. So our steel fabricator came up with the idea of making 14 pieces that would come up pre-assembled, and you would just bolt them on as you go out.
Built out from the building section by giant section, some weighing up to 50 tons. The result is an 800 square foot sky deck. But the final piece of the puzzle will be an immense triangle made of reinforced glass.
We felt that in addition to walking towards the peak, which I think will be exciting enough, we thought, why not make it a little bit more exciting and create a glass floor? Right now, there's nothing there. There's no glass. We're just looking down 1,000 feet. And it's pretty exciting, don't you think? It felt a lot more comfortable when the orange netting was across here. Now that it's down to like 2 or 3 wires, there's no need to get too close.
4 1,200-pound triangular sections of glass will complete the sky deck. 2 1/4 inches thick, it will allow visitors to take in the vertigo-inducing views from this mind-blowing vantage point.
I'll walk on it, I'm sure. I'll be goaded onto it, but I'll be nervous about it.
But this impossible project is attempting more audacious engineering, presenting further challenges.
We're moving the equivalent of about 600 elephants stacked up on top of each other, wearing 8 roller skates.
Can their innovative construction be taken to the next level?
It's very difficult to figure out that solution from an engineering standpoint.
New York's biggest ever impossible engineering challenge. Hudson Yards is a 17 million square foot real estate project constructed over a fully functioning rail yard. Perched on a specially constructed base platform above the tracks, this is a multi-tower mini-city. Multiple skyscrapers, a supersized mall, 14 acres of public land, all coming to life simultaneously. But perhaps the most inventive engineering on site is a unique arts venue known as The Shed. Engineer Eli Gottlieb is overseeing its build.
The shed is built up of 2 parts. One is what we've always thought of as the fixed building, which is the building that we're standing in right now. And then it has the sleeve that slides over the fixed building so that when it's not in use, it's actually retracted. But then when they have larger events and they need the space, they'll be able to roll the shed out to enclose the plaza and turn it into this larger venue that we can see here in front of us. There's really no other places like this.
The team is using a special inflated plastic to keep the shell as lightweight as possible, so the power required to move it is kept to a minimum. The drive system on the roof generates just 180 horsepower.
So we're up on the roof of the fixed building of the shed. You can see here are the main teeth from the drive mechanism that the actual shed motors will then roll against and drive the assembly back and forth. We're moving the equivalent of about 600 elephants stacked up on top of each other, in this case wearing 8 roller skates.
The roller skates are, in fact, 8 pairs of 6.5-foot high wheels running along heavy-duty rails. And in 2016, this retractable building was put to the test for the first time.
To see the shed move was actually fantastic, but it was also really surprising because it is so quiet that in fact a whole number of people actually kind of missed it because it happened and they sort of didn't hear it or realize that it was going on in that moment.
The vast 28-acre Hudson Yards is a series of separate construction projects. With many being built over an active rail yard, the challenges are undoubtedly huge. Although the site's southwest corner is clear of the main tracks, it posed an equally challenging problem. A massive tower had to be perched directly on top of a $2.4 billion Manhattan transportation hub. Just 3 years old, the 34th Street Hudson Yards station is one of the city's newest. With 1.5 million commuters coming into Manhattan every day, it's a key selling point for the development. But it presented the engineers with a challenge.
We've limited opportunities to put weight on the subway station and limited footprint to put weight outside the subway station. So we're looking for ways of putting as big a building as we can with the limited options we have at the foundation.
Lack of space for new foundations meant 40% of the tower block's weight had to be carried by the foundations of the subway station itself. Overloading was a real danger. The tower had to shed some weight without shrinking in size.
Our building is 51 stories of office space, and that's a lot of building to put on limited foundations. So the engineers needed to find solutions to lighten up the building as much as possible.
It seems impossible, but can engineers of the past shed any light on lightweight materials?
It's beautiful.
Kiptopeke State Park in Virginia. Engineer Megan Hart is off to discover how a material used to solve a wartime problem could help the team in New York.
During World War I and World War II, there was a massive manufacturing effort, and that took a lot of raw materials. The main one was steel.
Steel production went into overdrive to supply the military. This led to a shortage. But the U.S. Navy needed to build a fleet of supply ships. So how did they manage it? These are the Inspired solution, made out of an innovative version of a surprising material.
These are concrete boats. Can you believe that? And they actually float. Not only do they float, but they carried supplies during the war efforts.
The man behind it is Stephen J. Hayde. He was working in the Kansas City building trade in the early 1900s when he had a eureka moment. He noticed that shale stones left too close to the kiln during the firing process would bloat up when they overheated. The heat caused air bubbles to form in a honeycomb-like structure inside the stones, making them lightweight. So Hayde added them to cement and water to create his revolutionary new concrete, an invention that could help out Hudson Yards engineers.
So Stephen J. Hayde, instead of using traditional aggregate, which is heavy, it's just rock, he used an expanded shale. And that expanded shale is much less dense.
During World War II, 24 of these 330-foot-long concrete ships were made, the unexpected solution to the Navy's problem at sea. In New York, engineers draw on Hayde's discovery to solve a skyscraper's serious weight issue. 55 Hudson Yards is a whopping 780 feet high, and its sizable mass bears down on a major transport hub. To avoid overloading, the team had to save weight on the inside.
We're on the 47th floor of 55 Hudson Yards, and lightweight concrete helped us achieve a light building to go over the limited foundation we had around the subway station. So if we look above and below us, slab above, slab below, every floor on this building is made out of lightweight concrete. And we saved about 20 to 30% in weight overall. It made a huge difference. If we save 20% in weight, we can make the building 20% higher. So 20% more buildings, quite a bit.
The concrete floors are also lightweight because they're only 9 inches thick. But spanning the tower's vast open plan areas is problematic for such a thin floor. To keep floor weight down, meet the expectation of vast open floor plans, and maintain structural integrity, engineers must employ a revolutionary innovation from the past. Engineers must find a way to maintain the lightweight qualities of Hudson Yards' concrete floors while also preventing deflection or bowing under pressure. The team's solution is a pioneering technique known as post-tensioning.
Historically, post-tension technology in New York City specifically, it hasn't been used regularly. And this is the first building where it was used regularly in the slabs. So over our head, we can see white painted areas that say PT zone. That's where we're using post-tension concrete. Simply put, it's a high-strength cable that's pulled through the concrete that helps limit deflection.
A network of steel cables are threaded through liquid concrete. Hydraulic jacks apply massive tension to pull them taut. Anchored in place, the compressive force of the concrete is increased from 7,000 to 8,500 psi, reducing deflection, allowing a thinner, lighter slab.
With our high-strength lightweight concrete and using the post-tension slabs, it makes for the most robust system we can for a thin slab.
And while post-tensioning allows the team to build bigger and higher over the east side of the project, they have yet to break ground to the west, the other half of the $25 billion Hudson Yards development. A second, even bigger steel and concrete platform will be built above the tracks on the other side of the 11th Avenue Viaduct. 8 colossal buildings will be created. This city within a city will double in size.
We have 6 giant buildings around us, and we have a lot more coming in very short order. We're bringing more office space to New York City than there is in downtown San Diego.
But the engineers of this brand new neighborhood face another hurdle. They must defy New York's notoriously unpredictable weather. To be a success, Manhattan's newest business quarter must stay online 365 days a year. But maintaining a steady power supply in New York is a huge challenge. Hurricane Sandy caused the latest and most devastating in a long history of power cuts affecting the city.
When we lose power here in Manhattan, it's eerie, right? It's a large city. We're used to seeing it lit up, and we're used to seeing the city alive 24 hours a day.
Frank Norcross is in charge of Hudson Yards' energy supply team. He needs to find a way to protect the new development from power cuts.
The customers that will call Hudson Yards home can absolutely not afford to lose power at any moment. The things that we maintain to keep safety and security in a large city are under threat when we lose power.
So, in the face of hurricanes or other disasters, how do you keep the power supply running? The team needs to turn to the past to prevent history from repeating itself. Physicist Dr. Andrew Steele is at the Anson Engine Museum in the north of England, in search of a historic innovation that would blow steam power away. It was Nicholas Otto, a German salesman with a passion for engineering, who came up with an invention that transformed the 19th century.
This is what Otto came up with. It's called an atmospheric gas engine, and it's got a number of advantages over the steam engines that existed at the time. Firstly, you don't need a huge supply of water to run this thing. Secondly, you don't need a team of people. You can do it with just one person. And thirdly, you can have a load of these small engines scattered around the factory to operate individual machines, rather than having one massive steam engine to drive all the equipment in the whole place.
More powerful for its size than its steam engine counterparts.
So, that's a bit of physical labor. It's not like starting your car.
This new breed was fueled by natural gas.
Oh, wow, there we go. The way this atmospheric gas engine works is it's got a massive piston inside this cylinder. So then when that piston starts moving upwards, it draws in a mixture of gas and air. And when it gets to a certain point, somewhere around here, that pilot light, a little bit of that flame gets pulled into the cylinder. It causes an explosion, and that throws the piston up through the cylinder.
Essentially a miniature power station, Otto's single-acting cylinder was hugely successful. But it was his newly improved gas-powered model that could provide the solution for the engineers of Hudson Yards. Nineteenth-century German engineer Nicholas Otto had a stroke of genius while working on the early atmospheric gas engine.
This is the next iteration of Otto's design, and it's truly revolutionary. It uses something called the four-stroke cycle.
Unlike his previous engine, this makes 4 strokes of the piston for each ignition. First, the piston moves downwards, sucking air and gas into the chamber. Secondly, as the piston rises, the air and gas are compressed. Thirdly, it's ignited and the piston forced down. And on the 4th stroke, the exhaust gases are pushed out. The result is an incredibly efficient, reliable, and quiet engine.
The principle behind this engine, the four-stroke cycle, is also known as the Otto cycle, after the man who invented it. Engines like this were quickly deployed in factories, but they also rapidly found much more widespread use, particularly in the emerging automobile industry.
Nicholas Otto's innovation found its fame in light industry. Engineers at Hudson Yards are using his game-changing design to provide an immense power backup system. In 2015, 4 of the biggest 4-stroke gas engines in the world arrived on site in Manhattan. 44-ton, 20-cylinder, 4,600 horsepower beasts.
What we're looking at here is very comparable to what you'd find in the front end of any souped-up hot rod. It's an internal combustion engine that operates on a 4-stroke cycle. It just happens to be about 30 feet long and 10 feet tall. This is really the beating heart of the energy infrastructure here at Hudson Yards.
If New York's electricity fails and the city is plunged into darkness, the natural gas supply will kick in, and these monumental machines will take over the job of running the Hudson Yards power plant.
This plant protects Hudson Yards from power outages because it has the ability to operate in microgrid mode. What that means, very simply, is if there were an issue out on the utility grid, we could simply disconnect from the grid, then start restoring power that we source from our plant here.
When called upon, these monster engines will produce over 13 megawatts of power.
It is exciting to hear one of these engines fire up. It is the same sort of teenage boy excitement that you would find, turning over any engine, multiplied several fold because of the size of these engines. This engine has a heartbeat. This engine breathes. This engine creates energy, and you get a very visceral sense of that when the plant is running.
The Hudson Yards project represents impossible engineering on a staggering scale. A brand new 28-acre neighborhood built over a working rail yard.
Everybody knows the Manhattan skyline of New York, so when you change it, that's actually in some ways the most exciting thing. All of a sudden there's this monumental cathedral in the middle.
Every stage of this trailblazing enterprise poses extraordinary challenges.
The engineering on this site is such an example of incredible teamwork and incredible vision from so many people to be able to bring this to fruition.
Inspired by the work of the pioneers of the past, supersizing and breaking the mold themselves, the engineers are succeeding in making the impossible possible.
Coming onto the construction site, you get to appreciate it every day, but still every single day, it's a wow moment. I love this project.